Okay, Chapter 2, Analyzing Data, Section 2, Scientific Notation, and Dimensional Analysis. Remember that the big idea for the chapter, chemists collect and analyze data to determine how matter interacts. Okay, the objectives for this chapter: express numbers in scientific notation, convert between units using dimensional analysis, review vocabulary, quantitative data. Remember, that's having the number, the numerical information, how big, how little, how much, how fast, etc. New vocab, scientific notation, dimensional analysis, and conversion factor. Main idea for section 2. Scientists often express numbers in scientific notation and solve problems using dimensional analysis. So what is scientific notation? Scientific notation is when you take a number and you express that number between 1 and 10, that's the coefficient, and you multiply it by 10 raised to a specific power. So 1.26 times 10 to the second. Okay, so you have a coefficient and an exponent. To do this, you count the number of places, the decimal point must be moved, and you give it a coefficient between 1 and 10. Okay, the number of places moved equals the value of the exponent. The exponent is positive when the decimal moves to the left and negative when the decimal moves to the right. So 800 would equal 8.0 times 10 to the second. Okay, there's another example. And you can see when they're a minus number, when this number is a negative over here, that this number is less than 1. And when this is positive, it is greater than 1. Okay, so it is really a good idea to put all of your numbers in scientific notation. It makes the mathematical functions a lot easier. So when you're doing addition and subtraction, the exponents must be the same. Okay, so you have to make sure all your exponents are the same, and then you just add or subtract your coefficients. When you multiply and divide, it's a little bit different, but pretty simple. To multiply the coefficients, then you add your exponents. To divide the coefficients, then subtract the exponents. Okay, the exponent of the divisor from the exponent of the dividend. Okay. And go ahead and watch the movie.
Section C, Dimensional Analysis.
Relax. Although it sounds very complex, dimensional analysis is only a fancy term used to describe the process of converting units.
Here's the deal. We measure dimensions in units like the meters, liters, seconds, and grams we talked about earlier. Chemistry uses lots of different units, and sometimes you need a particular unit to do a calculation. If the unit you need isn't the one you're given in the problem, you have to convert units. You can convert units with the unit factor method. To use the unit factor method, write out the units, kilograms, seconds, meters, or whatever, for every quantity you're using in your calculation. Then carry the units through the calculation, treating them as algebraic quantities. Sounds tricky? It's not. Watch Willie the Wild Worm.
Wild Willie wants to visit his girlfriend Lily, who lives in a compost heap 7.92 miles away. Willie can only wiggle along 1 centimeter at a time. How many centimeters poor lovesick Willie have to wiggle to cover the 7.92 miles between him and his beloved? Well, we have a problem with this problem. Willie measures his travels in centimeters, but we've measured his travel in miles, so we have to convert to centimeters, Willie's unit of measurement.
Using the unit factor method, multiply the quantity you start with by the appropriate conversion factor until you get the unit you want. In this case, convert miles to feet, feet to inches, and inches to centimeters, since centimeters is the unit you need for your answer. 1 mile equals 5,280 feet, 1 foot equals 12 inches, and 1 inch equals 2.54 centimeters.
To find out how many centimeters Willie has to wiggle, we set the problem up this way. 7.92 miles times 5,280 feet over 1 mile times 12 inches over 1 foot times 2.54 centimeters over 1 inch. The first conversion factor, the one converting miles to feet, looks like this.
5,280 feet over 1 mile. 5,280 feet is equal to 1 mile, so in our equation, multiplying by 5,280 feet over 1 mile is just like multiplying by 1. You know that multiplying anything by 1 doesn't change the value. All we're changing here is the units, so this is when we treat the units like algebraic quantities. Remember crossing stuff out in algebra problems? When we cancel out the miles, feet, and inches in the problem, then multiply it through, we get 1.27 times 10 to the 6th centimeters. It's like we multiplied 7.92 times 1 times 1 times 1, changing only the units, not the values. And hey, don't forget the sig figs. 7.92 only has 3 significant figures, so the numbers in the answer can only have 3 significant figures.
Hey, babe, fix me a sandwich, will ya?
Okay, dimensional analysis is a systematic approach to problem solving that uses conversion factors to move or convert from one unit to another. Conversion factor is a ratio of equivalent values having different units, such as 12 inches equals 1 foot. Okay, so you write your conversion factors out. Conversion factors are derived from equalities such as 1 dozen eggs equals 12 eggs. Okay, percentages can also be used as conversion factors. They relate to the number of parts of one component to 100 equal total parts. Okay, so here is an example. You have 32 people times 2 bottles divided per person times 1 8-pack divided by 8 bottles. That means 32 people need 8 8-packs to have enough to drink. And see how your units cancel out. This is on the top, this is on the bottom, they cancel out. This is on the top, this is on the bottom, they cancel out. You're left with this unit. Okay, so here are some conversion factors. Okay, you're used to those. Here are some that you might not be used to that we will be using. See if you can answer these 2 questions. Just more practice with dimensional analysis. I can find. Okay, notice how that is in scientific notation. Okay, your days, notice your days are on the top here. These 2 need to be flipped around so the days cancel and that the hours cancel. How would you set this one up? Okay, steps to solving the problem. First of all, you need to read through the problem and make sure you understand it. Identify the data. Write down a unit plan from the initial unit to the desired unit. What you're given in the problem should go on the left. what you're looking for or your desired unit needs to be on the right. Select the appropriate conversion factors and make sure you have the conversion factor set up so that it will cancel from the top to the bottom. Change the initial unit to the desired unit, cancel units, and check. Always double check your math. Use a calculator if need to double check your math. Okay. Always give your answer in significant digits. Significant figures and significant digits in scientific notation all have to do with one another. Okay, see if you can figure this one out. Okay, what is a scientific approach to the problem solving that converts from one unit to another? And your answer is all right.